Hey y'all. So today's lesson, you are going to need a calculator. Let's go ahead and pull up your calculator. And it is percent error. Percent error. This is a brand new topic in North Carolina and a brand new topic in 7th grade. It's new to the Common Core. So I've researched it and I've learned about it, and here is what percent error is. Is the error between two measures expressed as a percent. The error between two measures, and mostly this is used in science classes as you get older and do probably like a chemistry where you are measuring different chemicals and different substances. And so typically percent error is going to be in science, but we're going to do some math problems with percent error. And the way you find percent error is you're going to set up a proportion.
Jason Mueller, go back to room 720. Jason Mueller, go back to room 720.
Okay, so you are going to set up a proportion, percent x over 100, and then the amount of error goes on top, and it's very similar to percent of change. The amount of error is found by subtracting. Like if you think you weigh 100 pounds, but really you weigh 102, then you were 2 pounds off. That was your error, 2 pounds off. And then the actual or the exact amount would go on the bottom, like whatever it really is, the real value, the exact value, the actual value, that goes on the bottom. So similar to percent of change. Someone's yelling out in the hallway. All right, so example 1. John thought his countertop was 5 feet. The actual measure was 4.5 feet. What's the percent error? So he thought it was 5 feet, but the actual measure was 4.5 feet. So we're going to subtract the two. 5 minus 4.5, and we get 0.5. And then the actual or the real value, the exact value has to go in the denominator, and the actual value, it says right here, the actual measurement was 4.5. And then equals x over 100. So now we can cross multiply 0.5 times 100, divide by 4.5. So he had an 11.1% error. He had an 11.1% error, so that he was off by about 11%. Okay, pause it so you can write it down. Example 2, I estimated 260 people would come to the dance. So we have a dance, and I think about 260 people will come. Mostly 6th graders, mostly, to the dance, but actually 325 came. Again, actually, find the percent error. So again, we subtract 325 minus 260. I'm going to use a different color. And that gives us 65 people. And what is the actual amount, the real amount? How many people actually came to the dance? And so this is 325 equals x out of 100. So we cross multiply 65 times 100, and then divide by 325. And x is equal to 20% error. 20% error. So I estimated, my estimation was 20% off from the actual amount. 20% error. All right, so example 3, copy it down. The report said the parking lot held 240 cars, but we counted only 200 spaces. What's the percent error? So the report said 240 parking spots, but we only counted 200 spaces. I don't know who's going to go outside and count 200 spaces, but somebody went outside and counted 200 spaces. So we subtract 240 minus 200, and we get 40. And then what was the actual, what was the exact? How many parking spots did we physically count? And we know that there are 200 parking spots. So now we cross multiply, then divide by 200, and x equals, funny enough, 20%. Again, 20%. I promise they're not all going to be 20%. But that means our report, there was a 20% error in the report, that they think that there are 240 parking spots, but there's only 200. Alright, you try number 4. I want you to try it on your own, pause the video, and then when you're ready to see it, press play and I'll explain it. Okay. Mr. Klein thought he was 6 feet tall, but really he's only 5.75 feet tall. What's his percent error? Now, I don't know, I'm sure Mr. Klein is 6 feet, or even taller than 6 feet. This is just an example. So we're going to set up a proportion. And what was the difference? 6 minus 5.75, so 0.25 when you subtract. And what was the actual amount? What was the exact amount? But how tall is he really? He's 5.75. So we have to cross multiply. And then divide. And it comes out to be 4.34, so 4.3%. So he was only off by about 4%, which is not a large percentage. So his error is 4%, about 4%. So tomorrow you can ask Mr. Klein how tall he is and see. I'm sure he's probably taller than 6'1". Alright, example 5 is about Zoe, and obviously the question is, what's the percent error? Now this one you're going to try on your own, and we'll go over it in class tomorrow, so I'll read it to you and then you do it. Zoe measured the volume of her soda and got 12 ounces. Her bottle said 14 ounces on the label, so she had like a 14-ounce bottle of soda, and she poured it out into a measuring cup, and she actually measured, and she got 12 ounces. What's the percent error? So in your proportion, you know you're going to have x over 100. So then you fill out the rest of that proportion and solve it. And what is Zoe's percent error? And we'll go over it tomorrow.